All right, so this is the third most missed question. This is another great question. It focuses in on integral defined functions, which we spent quite a bit of time with this year. All right, so first thing they give us down here is they give us that g of x, all right, is defined by that integral defined function. And they ask on what open interval is g negative and decreasing. All right, so first thing we need is when it is negative. All right, so I'm going to look at that from an area perspective. So g is defined as the area from 0 to x. So if I start at 0 here, all right, as I move to the right and move to 1, all right, g is going to be negative through there. Now at this point I have negative, the width is 1, the height is 2, and it's a triangle, so I have 1/2 of 2, which is an area of 1. All right, so as I move out to this side, I'm going to be offsetting that all the way until 2. All right, so it's still going to be negative up until 2, but not inclusive of 2. All right, so we're negative, right, on the interval from 0 to 2, not inclusive of the endpoints, because initially we're going to be 0 to 0, which is the area of 0, and when we get out to 2, those two triangles are going to offset each other perfectly. All right, now we're going to take a quick glance. What if I go in the other direction? All right, if I go in the other direction over here, all right, we're going backwards, so that's going to switch the sign. All right, so it's below and backwards. That's going to be a positive. So that side's actually positive. So the only area where g is negative is on that 0 to 2. All right. So then the next thing we're going to look at is decreasing. Now decreasing is based on the derivative. So the derivative of g is g prime, which is going to equal f of x from our fundamental theorem of calculus. All right, so f of x is what we're looking at, and we need that to be less than 0 for this to be decreasing. So I'm going to look at my graph, and basically my less than 0 is the line right there. So I need anywhere on this graph where it's below that, which is going to be from our negative 2. All right, so we're going to say decreasing from negative 2 all the way up through 1, because those are the places where f of x, the actual graph function, is below 0. All right, now what I need to look at is I need to look at these two together and say, what's my overlap between those two? And it looks like I have an overlap from 0 to 1. All right, that seems to be the overlap between those two. So 0 is less than x is less than 1. That's the only section that satisfies both characteristics, so we're looking at a correct answer of C. All right, and that would be our correct answer for this problem. Again, we really want to focus on this idea that if I have g of x equals the integral from 0 to x of f of t dt, the derivative of that is going to be f of x, and then the second derivative of that is going to be f prime of x. All right, this connection is something we use quite a bit, and it will most likely show up on a free response item if we end up having free response items on our test. Hope that was helpful. Thank you.